Hello everyone. Today we are looking at another Leetcode problem. This is 3304, which is find the kth character in a string game. So Alice and Bob are playing a game. Alice starts with a word, and the default state of the word is a single character A. Now Alice has to keep generating the extension, the word extension using the rule given below. And the rule goes like this. You have to generate a new string by changing all the characters to the next character. So the next character of A is B, the next character of B is C. That results in BC. And then we have to take these two and concatenate to generate a new word. So that becomes AB, BC. Now the process repeats. You take the output as the input again and take the next character of this. So we get B, here you get C, this gives C, this gives D. Now concatenate that with the original word, you get A double B C and B double C D. And this process continues till we get to the kth character, and that is what we have to return in this problem. So the problem is quite straightforward. That's all there is to the logic. There is a little bit of a concept in terms of uh, in terms of calculating the next character, especially when you get to the last character Z, you have to go back to the starting, which is A. So if you look at the Unicode number line, our A sits on 97 and our character Z sits on 122. And what we can do is use the modulus operation such that when it goes beyond, we reset it back to A. Now this works very well when we are starting at 0, right? Because what does modulus give us? Modulus gives us a remainder. So let's say if I am using modulus of 6, 0 modulus 6 gives me 0, 1, 2, 3, 4, 5 gives me 1, 2, 3, 4, 5. And then when I come to 6, it resets back to 0 and so on. And so that is what we want to do. So if we have at 0A and if we go on, we have 26 characters, right? So our Z will be sitting on the 25th index. Okay, and you can count the number of characters here. So n minus start index plus 1, so 25 minus 0 plus 1 gives me 26 alphabets that I am supposed to have. So this is good. But the problem is A is not sitting at 0, it is sitting at 97. So what we need to do is a little bit of window shifting. So this particular window, I will have to shift to this region, quickly compute the next character, and then shift back here because only when I have this value, I can tell what character this is. Okay, so this is the only tiny tricky part of the problem. But even this, actually, if you want to avoid, you can write it as a simple if condition. So you can say whenever your character has come to Z, the next switch that you don't use the formula, but rather um, you just take A, you just return as it is. But for rest of the characters, you can convert it to its Unicode, do a +1, then read the character back again. But since we are anyway switching to Unicode and then getting the next character, what I'm going to do is do end-to-end using this conversion. So for this conversion, I'm writing a lambda function. Okay, so let's see how that works. Okay, so lambda is going to take an input x. Okay, and maybe let me keep this thing in the range so we can refer to this. So the lambda function is taking an input x. First thing that I need to do is I need to find its Unicode value. So let's do that in Python using ordinal function. I get the value. Now I need to subtract a from this to adjust it to this range 0 to 25. So minus ordinal of small a, because we're only going to have small letters. Now once I have done this, now I have landed somewhere in this space. Now I can safely increment 1. Okay. So now I have some value that is in this range, good enough for me to now take modulus of 26. So that is what happens. So I take the modulus of 26, and when it gets to 26 itself, if I was at C, adding 1 to that takes me to 26, which will reset and go back to 0. And that will give me the value A. So once I have done this computation and gotten that value, I can add ordinal A to it to get back the original character. Now, right now, this output returns a Unicode. I need to convert it to a character. So I have to pass it to chr in Python, and that is it. This is the function that does everything. Okay, now let's write the pseudocode real quickly. So let's say def generate kth character. Have been given k as an input. Now I'm given only k as an input because the word equal to a is a default. That we have been given. Alright, and so we set that the word is equal to a, and then we also say if k is lesser than or equal to 0, that means I'm trying to look at 0th or lesser than 0th character, which is not possible. So let me just return an empty string for that. And then I need a helper function that helps me generate this. Now this piece of code that I've written is helping me only do the character switch. So from A, I go to B. But I have multiple of these characters, right? So I need to put them together. So let's use a helper function. Let's say def generate new word, which takes the current word as input. Okay, and we say new character is my this lambda function, and I'm not going to write it. I'm just going to leave it as it is. Then the next thing that we do is generate the new word, which is equal to join or join of passing the existing words character to this new ch lambda. So new underscore ch, pass the current character, which is for ch in word. Alright, for every ch in word, generate a new character and join it. This gives me the newly generated word, and then I can return word plus new word. Alright, and so I have to do this. I have to call this helper function till I have the kth character available. So while len of word is lesser than k, because I want my len of word to be greater than or equal to k, so I can take the kth character. Well, till this is the thing, you say word is equal to generate new word of the current word. That's about it. And then you return word of k minus 1 to take the kth character. This is for the code logic. Now let us quickly look at the time complexity as well. Now, if you haven't already noticed, what is happening is that every time we generate a new word and we concatenate, we are actually doubling the string size. Okay, so we started with 1 1 and we double, so we add these two together, and then we add 2 plus 2, string size of 4, 4 plus 4, string size of 8, 8 plus 8, string size of 16. And so you can see every time this is growing by 2. So this is an exponential. Okay, and so we're doing this. So what we're doing is we are doing this n times. Okay, and we're doing this n times till we get to a size of k, because we want a word to be of size greater than or equal to k. So we are doing this at least of till k is equal to 2 power n. So then n is equal to log times k. So the number of steps that we need to do, or the number of times we need to compute, is log of k. And so our time complexity is log k. That is it for this problem. Hope this was a easy, fun one. Let's see what comes up tomorrow. We'll see you again with tomorrow's problem. Thank you. Bye bye.